Given angle theta is in standard position with its terminal arm in quadrant 4 and cos equal to 2/5, what does this make you feel like? Even before we get to what the question is. A triangle question. Does it feel like a triangle question where they're telling you what quadrant it's in and what the cos or the sine is? So it's probably going to be that strategy of drawing a triangle is going to help you. Now if I draw the triangle here are my 4 quadrants. I know that it's in quadrant 4, so I can draw the triangle back to the nearest x-axis. This would be my reference angle for theta, and cos of theta is 2/5. So this side will be 2, this side will be 5. How good are your a squared plus b squared equals c squared skills? Good. This will be the square root of 21. Excellent. Well, when we label the sides of the triangles, I always label them as positive and negative. As positives, because they're actual lengths of that triangle. Okay? When we determine things like sine and cos, cos is positive in quadrant 4. Sine is going to be negative in quadrant 4. So we have to be aware of those things. So when we're trying to find sine 2 theta, it's going to be equal to, well, that 2 theta should make you think of your double angle identities. We don't have the angle 2 theta anywhere on our triangle. The only angle that we have labeled is the angle theta. So if I rewrite sine of 2 theta as 2 sine theta cos theta, my triangle tells me what sine theta is. My triangle tells me what cos theta is. And if I use both of those, so what will I plug in instead of sine theta? Negative root 21 over 5. What will I put instead of cos theta? 2 over 5. And again, just like we noticed when we did that survey earlier, you don't know what theta is. We never figure out what theta is. We know what cos of theta is. We know what the ratio is, even though we don't know what the angle is. I mean, you could find the angle if you wanted to use your calculator to find that reference angle, and so on. But right now, it's not asking us to find the angle theta, and it's asking us to find an exact value. So that means we can do it without our calculator. Right now, we just have to write this as a single fraction. How do I multiply fractions? Multiply the bottoms. I'll get 25, multiply across the tops. I'll get negative 4 root 21. Yes? It's going to be negative because sine, if it's in quadrant 4, according to our cast rule, sine is negative in quadrant 4. Okay, so we figured out part A, sine of 2 theta. In part B, we're asked to find cos of 2 theta. So now you have a choice of those 3 formulas. And in this one in particular, the way that we've set it up, I would say all of them are equally as fast, but I do have one that's my favorite in this case. Now the one that I would pick as my favorite of the 3 would be this one. Anybody know why that one's my favorite in this question in particular? Because cos of theta, right, cos of theta is given. So you see that the other 2 formulas have a sine of theta? We figured out what sine of theta is, right? Negative root 21 over 5. It wasn't very hard to figure that out. But there is a small possibility that when you did your a squared plus b squared equals c squared, that red value, which is square root of 21, you could have made a mistake. It's possible. All of us have made mental math errors this year in this class at some point or another. So it's possible we could make a mental math error when figuring out this red value. That's why I put it in a different color. But if we use the formula that just uses cos, cos was given to us as 2/5, then we don't have to worry about any other little mistakes we might have made along the way. So plugging in our values, if cos of theta is 2/5, how are we going to write cos squared of theta? We just have to square 2/5. Because cos squared means cos of theta times cos of theta. So it would be like 2/5 times 2/5, or 2/5 squared. Now order of operations come important here. What would you do first? Square it. So this will be 4/25. Then multiply. And I'm going to change the 1 to 25/25. So I have my common denominator, 8 minus 25. Negative 17/25. Now I'm going to show you that had you decided to use a different formula, okay, a most common strategy when there's a bunch of formulas and you don't know which one to choose, you choose the first one. So let's say you chose the first one, cos squared theta minus sine squared theta. Cos was given to us. It's 2/5. Minus sine. We already did a squared plus b squared equals c squared. What was sine of theta? Negative root 21/5. Here too, this is where many of you would make a mental math error and still get the right answer. That negative in quadrant 4, how often have you forgotten negative this year? Yeah, everybody's done it at least 3 times, probably, right? In your homework, in assignments. We always forget negatives. And in this question, when you square, oh, this one's squared too. This will be 4/25 when it's squared, minus. And squaring a negative becomes positive. So even if you made that mistake, it wouldn't show up in your final answer. But everybody who's trained to mark the final exam, they have a specific check in the marking guide that says make sure you check that that negative's there. If it's not, even though their final answer is right, you have to deduct a half a mark. So even though we get the exact same answer whether we had put a negative or positive there, it is important to write things correctly all the way through. Okay, so we get negative 17/25. Look at our answers for part A and B. Theta's in quadrant 4. If you double theta, what quadrant is it in? It goes. And in this, it could be in different places depending on what your angle is. But in this case, if you doubled it, what quadrant is it going to be in? And the answers are told to you in part A and part B. It's in quadrant 3. How did you know? Cos of 2 theta is negative. So that means 2 theta is in 2 or 3. Sine of 2 theta is negative, which means it's in 3 or 4. And the only place where they're both negative would be in quadrant 3. Okay, so for period 3, we'll work on question number 9.